I welcome you all once again this evening. Today I'm going to discuss about differential equations. It's a topic in further mathematics. So, as I've promised you guys, everything that I'm studying, I'll be bringing it here, and you know what it takes to become an engineer, and you know what it's happening inside an engineering class, and if you know anyone who wants to become an engineer, and if you are interested in becoming an engineer, or if you're interested in science and technology, this is the right place. So let me not take much of your time. Let's get started. Um, so what is a differential equation? A differential equation is just an equation with a derivative inside of it, and this happens a lot in different cases, um, even in engineering, where we have maybe the rate of flow or anything where variables changes, and this will affect generally maybe the output of some work, something like that. But here in mathematics, we just try to solve uh, the equations for different cases. So let's begin. So here I have some examples. For example, I have this equation. Then I've written why this is first order differential derivative, which is equal to 25xy. So how do we solve such an differential equation? So this is the way we can write the derivative of y with respect to x. So this is the same as dy dx is equal to 25x y. Let's just say this one is example 1. So we need to split these values. So taking y to the left side, we're going to have dy divided by y is equal to 25x dx. Now we need to integrate both sides, and on the left side we're left with ln modulus of y is equal to 25x squared, or divided by 2, then plus our constant c, because when we integrate, we are supposed to remember every time we have a constant. So taking exponent of both sides, we're left with y is equal to exponent of 25x squared divided by 2, then multiplied by exponent of c, and exponent of c is just a constant. We have exponent of 25x squared divided by 2 multiplied by the constant k. So now we can rewrite our equation like this: y is equal to k exponent of 25x squared divided by 2, and this one is our solution. Okay, now let's take another look on another example where we can use the same method that I've just illustrated. That's the method of splitting. So given an equation x plus 4 all multiplied by dy is equal to xy dx. Okay, given this kind of an equation, we need to split the variables just like we did before, and let's see how we can solve it. And this is also another way we can have a differential equation. So at the left side, I'll be left with dy divided by y is equal to x dx divided by x plus 4. And like always, we need to integrate both sides, and on the left side I'm left with ln of modulus of y is equal to now look at how I'm going to write this expression. I can write it like x plus 4 minus 4, or divided by x plus 4 dx. This 4 minus 4 will remain 0, but I've written this way so that I can partialize this fraction. So I'll be left with ln is equal to the integral of 1 dx minus the integral of 4 divided by x plus 4 dx. So here it gives me this, and this would be just x, and this would be minus 4 ln modulus of x plus 4 plus a constant c. Taking exponents of both sides, I'll be left with y is equal to exponent then of x multiplied by exponent of ln, then I'll have x plus 4 to the power negative 4, then plus, then also plus multiplied by exponent c, but this one is a constant, so we have y is equals to our constant k exponent of x. This exponent and this ln will cancel, and I will be left with multiplied by x plus 4, that is to the power of minus 4, and I can rewrite this in this way: k exponent of x, or divided by x plus 4. Then this one is our solution. So that was the first method. It was the method by just splitting, but in some situations we are not going to be able to split, so I'll just illustrate another way we will solve if we can't split the variables. So for example, if we have an equation like the differential of y to the first order is equal to 2x plus y. In this case, we can split the variables. So what are we going to do? We are going to write y as a function of u multiplied by v. So here we are going to have y is equal to uv, and the derivative of y would be equal to u multiplied by the derivative of v plus v multiplied by the derivative of u. Then we're substituting this into our Euler equation. We're going to have, in the place of the derivative of y, we're going to place our new expression, which is equal to 2x. Then in place of y, we're going to write uv. Then let's make these terms in uv, let's put them in one side. So we're going to have u multiplied by the derivative of v plus v multiplied by the derivative of u minus uv is equal to 2x. At once, let's try to factor out v from this equation, and we have plus. Then we can factor out v, and we're left with u minus u. The derivative of u minus u is equal to 2x. So once we have this expression, it is easier for us to continue working this problem. It is easier if we imagine this to be equal to 0. So I'll have u, the derivative of u minus u is equal to 0. And once I have in this, like we have shown below, this is du dx is equal to u. Once I have this, I can actually split, and I'll have du divided by u is equal to dx. Then integrating both sides, I'll be having ln modulus of u is equal to the integral of dx would be give me x, and from this u would be equal to the exponent of x. Now let me put this equation to be 1, and substituting u in the equation 1, I'll have this expression u multiplied by v1 is equal to 2x. Since this we have assumed this equal to 0, so I have the exponent of x to be equal to u, and here I would have the derivative of v multiplied by the exponent of x is equal to 2x. And now I can rewrite like dv dx multiplied by exponent of x is equal to 2x. So let me rewrite it. dv dx multiplied by exponent of x is equal to 2x. Now I can split, and on the left side I'll be left with dv is equal to 2x multiplied by exponent to the power negative x dx. From here I can integrate both sides, and on the left side I'll be left with v, and on the right side, you remember the integration by parts. So generally integration by parts, I'll choose what I want to make u, what I want to make the derivative of v. Then if I make this one the derivative of v, then if I make this one u, I'll just need to write it in this way. X, the derivative of v would be this one, and I will just integrate it. It's u, so it will be negative exponent of negative x minus the integral, the derivative of x would be 1 multiplied by negative then dx. Then v is equal to negative x exponent of negative x then here I'll have, in if I integrate this negative and this negative would give me a plus. If I integrate this, I'll get another negative, and the negative of x exponent of x, and this is my v. And let me rewrite factoring out exponent of x. I'll have negative 2 exponent of negative x, x plus 1. And earlier we had substituted y with uv, and now u is equal to exponent of x and v is equal to negative 2 exponent negative x, x plus 1. So our y would be given by uv, which is this multiplied by this, which is going to be equal to exponent of x multiplied by negative 2 exponent of x, then x plus 1. Then this cancel this one, and I will have negative 2x minus 2. And this is my y, then plus a constant. But now minus 2 plus a constant, just a constant, so I have y is equal to negative 2x plus k, and this is our answer. Okay, now let's look at another example. It's not always clear in some cases which method should you use, but so other cases, even though they require splitting, but some substitutions may be required. So now let's just look at another example, and we see how we can go about it. And remember guys, some of these problems you will never solve them in your life if you haven't seen them anywhere. This is about is something about mathematics. You need to see how it's done for you to be able to solve it. So I'm not going to wait long. Let me just, so given an example of an equation, let's say y squared minus 2xy all multiplied by dx plus x squared multiplied by dy is equal to 0. So here what do we need to do? We just need to divide all the expression by x squared. So I'll have y squared divided by x squared minus 2y divided by x all multiplied by dx plus dy is equal to 0. Once I have this kind of an equation, I can easily see that I can substitute y over x being equal to u, and this means y is equal to ux, and dy is equal to u dx plus x du. And after this I need to rewrite my equation, and this will become u squared minus 2u minus 2u, u squared minus 2u all multiplied by dx plus, then in place of dy I'm going to write this. I have u dx plus x du is equal to 0. So now regrouping these terms, I will have u squared minus 2u plus u all multiplied by dx plus x du is equal to 0. And now it's simple. I can split these variables, and on the left side I'll be left with dx, then multiplied by negative 1 over x is equal to du divided by u squared minus u. So now I can easily integrate both sides, and here I'll get negative ln x is equal to, here I can rewrite it in this way, du on the right side, u multiplied by u minus 1. And once I have the integral of this kind, I can partialize my fraction. Here is how I do my partialization, and I'll have 1 over u minus 1 is equal to a over u plus b over u minus 1. Let me write this right side as a combined fraction. I'll have 1 equal to u minus 1 is equal to u is a common fraction, common denominator, and this one would be a into u minus 1 plus b multiplied by u. So now the denominators are equal. I can equate the coefficient, and I can equate the coefficient of the numerators to find the value of a and b. So right now from this I have an equation 1 is equal to a u minus a plus b u. So coefficients of u on the left side is 0, so we have a plus b equal to 0, and constants it's 1 on the left side, which is 1, and on the right side it's equal to negative a, and this means a is equal to negative 1, and from this equation it gives b equal to positive 1. So now rewriting my equation, I would have negative ln of x is equal to the integral of negative 1 divided by u du plus the integral of 1 divided by u minus 1 du. And now this is simple integration, and I'll just have negative ln of x is equal to negative ln of u plus ln of u minus 1 plus a constant c. So now taking exponent of both sides, I'll have 1 over x is equal to the exponent of this one would just give me 1 over u multiplied by u minus 1 multiplied by exponent of constant c. So exponent of constant c is just another constant, so I can rewrite it as 1 over x is equal to u minus 1 divided by u multiplied by k. And from our earlier substitution, y over x is equal to u. Now in place of u we put y over x, and I'll have 1 over x is equal to k multiplied by y over x minus 1 all over y over x. Now simplifying this expression on the right side, I'll have 1 over x equal to k. Then this will multiply by x, kx, and I'll have y minus x over x, all divided by y, and this cancels this one, and I'll be left by 1 over x equal to k multiplied by y minus x, all divided by y, and this gives me y equal to kx multiplied by y minus x, and this can be written y divided by y minus x is equal to kx, and this is our answer. Thank you for watching up to the end, and see you next week with what I would have learned next week. Okay, guys, I'm giving you live as I'm getting it, is the way I am giving it to you. So stay tuned. You will know what's happening in the engineering class, and you guys, these topics, if you like engineering, science, and technology, they will help you much. And if you have kids in school, and if you have friends in school, this is what they're going to face if they are going to become engineers. And just inform them to keep them on track so that they won't get lost. Thank you again for watching. See you next week, and stay tuned.